Welcome to the Arithmetic Zone, and welcome to our first math video in a while. So today, we're going to tackle modified u-substitution. Now, to understand this video, you do need a basic knowledge of how u-substitution works and antiderivatives. So if you don't know any of that, then this video won't be that useful. Anyway, the problems I'm going to go over today are when u-sub almost works. It's just that we need to modify some x term to be in u. So let's try to do u-sub on this example right here. You would make u x plus 1, which is in the denominator, and then du is the derivative of u, which is just 1, and dx. But you see the issue with this, right? The u and the du, they do not account for the x in the numerator, and it's not like I can just split up this fraction. There's only a single term in the numerator. So we're going to have to do something different. We're going to have to take this u that we got and then write it in terms of x. So x would be equal to u minus 1, which I just got by subtracting this 1 to the other side right there. So now we actually have all the necessary components to rewrite this integral. And if I try to exit this drawing and then show you on the next slide, there it is, u minus 1 over u times du. And now we can actually split up this fraction into two different terms. So the integral of 1 minus 1 over u du, and suddenly this becomes possible to integrate. Now the integral of 1, for du, it would not be x, it would just be u. And then the integral of 1 over u is just ln to the absolute value of u, because that is just u to the negative first power, and you can't do a basic power rule when the exponent is negative 1. And then, of course, plus c for the constant of integration. So now you just want to replace u with what x originally was, which, if you remember, it was just 1 plus x, or x plus 1. So 1 plus x minus ln of 1 plus x plus c. And that is your final answer right there. Now let's look at this second example right here. And this example is going to show us why modified u-sub is so much better for these kinds of problems, and it saves so much time. So one person I know, who I won't name, would definitely try to expand this whole integrand out, even though it's to the 5th power. They would definitely just multiply this 5 times and then just do power rules from there. You could do that, but that's too much work. Let's try to use modified u-sub instead. So you want to make u x minus 3, and then du once again is just 1 dx. I apologize for my slow writing. And again, I do not account for this x in front of this term right here. So again, I'm going to have to write x in terms of u. So that would just be u plus 3 by adding 3 here and then adding 3 here to get that. So now I can actually rewrite this whole integrand by using these u's and these x's. So that would just be u plus 3 times u to the 5th power du. Now after that, you want to distribute the u to the 5th power to both terms, u and the 3 inside the parentheses. So you would get the integral of u to the 6th power plus 3u to the 5th power times du. And now all you have to do is basic power rule. So you would have u to the 7th over 7 plus, and then this would turn into 3u to the 6th power over 6, which is just u to the 6th power over 2. And then, of course, the constant of integration plus c. So finally, taking the u and then turning it back into what it originally was, we get x minus 3 to the 7th power over 7 plus x minus 3 to the 6th power over 2 plus c. And that is our final answer right there. So I hope you guys found this little neat trick to be useful for problems like these where u-sub almost works. There's many other ways to modify problems that can be solved with u-substitution that I can show, but they require a lot more work and much more understanding of trigonometry and AP Calculus BC level of knowledge. Anyway, I'll see you guys next time, and I hope you enjoy your day.